So here's another example of an inequality with an absolute value. And the first thing that we want to do is get the absolute value by itself on this side of the equation. So we are first going to subtract 5 from both sides. And that leaves us with 2 times the absolute value, negative 7x minus 3 is greater than or equal to 4x minus 14. And since this is being multiplied by 2, we're going to divide both sides of the equation by 2. So those 2's cancel. So we have absolute value of negative 7x minus 3 greater than or equal to, and then we can divide each part of the numerator by 2. So 4 over 2 is 2, so that leaves 2x minus, and 14 over 2 is 7. So now that the absolute value is by itself, we can split this into 2 inequalities. So the first one is going to be negative 7x minus 3 is greater than or equal to 2x minus 7. So everything is the same. We just took the absolute value signs away. And the other the other inequality is negative 7x minus 3, and then we switch the greater than to less than or equal to, and then we change the sign of each piece here. So 2x becomes negative 2x, and 7 becomes positive instead of negative. And so now we can solve each of these. So we will get all the x's on one side and everything else on the other side. So we'll add 3 to both sides, and we will subtract 2x from both sides. And so now we have negative 9x is greater than or equal to negative 4. And then we will divide by negative 9. And anytime we multiply or divide an inequality by a negative number, we need to switch the sign again. So since we divided by negative 9, this sign is going to change to a less than. So now x is less than or equal to negative over negative, so positive 4/9. And for this one, we'll do almost the same thing. Add 3 to both sides. We're going to add 2x to both sides. So negative 5x less than or equal to 10. Then we're going to divide negative 5 and negative 5. And again, we're dividing by a negative number, so it's going to be x. Now it's going to be greater than or equal to 10 divided by negative 5 is negative 2. So now we can put our solution on a number line. So here's 0, and then we are going to need a negative 2, and then 4/9, that's pretty close to a half. So if here's 1, I could have spread these out a little bit more, but that's okay. So then this would be 4/9. So since we have an equal sign on both of these, we're going to place a closed circle or a point on each of those solutions. And so that means that these numbers are included in the possible solutions for this inequality. Then from -2, x would be greater, so from here it would go that direction. 4/9, x is less than, so from 4/9 it would go that direction. So that means we're going to shade everything in between. So everything in the shaded area, or every point in the shaded area, could be plugged in as x into the original inequality, and it would result in a true statement. And so we can test that by plugging in 0. Anytime 0 is in your solution set, that's the best thing to plug in. So, because it's so much faster. So we'll plug in 0 plus 5 and then we'll simplify. So 7 times 0 is 0, and then -3 plus 5 greater than or equal to 4 times 0 is 0, -9. And then we have 2 times the absolute value of -3 plus 5 and -9. The absolute value of -3 is 3, so now we have 2 times 3 plus 5 is greater than or equal to -9, and 2 times 3 is 6, and 6 plus 5 is 11, so 11 is greater than or equal to -9, and that is true, and so that supports our solution.